Locktronics, and that would include automobile, diesel, hybrid, alternative fuel technologies, and complete training systems for ESE certifications. So Locktronics is in thousands of institutions around the world, and it's anything from primary school right up through college in physics, engineering, computer science, aviation, automotive, et cetera, robotics, electrical installation. And there are 40 different curriculum packs, so it comes with full curriculum. And that's my introduction, Liam. So if I can turn it over to you and John, that'd be great.
Yep, that's no problem. Thanks for that introduction. I just wanted to extend my thanks to Jeff, Cheryl, and the team at TechEd Systems for facilitating this. We had a really good session last week with some on our electrical kits, and I believe, Jeff, you have a recording of that you could send on to anyone who is interested in seeing the information regarding our electrical kits afterwards. I am recording this webinar, so I'll make sure that we share the recording of this with you later on today, hopefully. I just wanted to kind of expand a little, just briefly, before I hand over to another colleague of mine, about our company, Matrix. Coincidentally, the same sort of year that we were founded as TechEd Systems, 1993. I have my colleague John Dobson, who's on this session as well. John will be delivering the content of this webinar, and the main content that we're going to talk about today will be our automotive kits. Now, this is a really good time to be talking about our automotive kits. We've been working in the automotive sector with Locktronics for many years. The brand of Locktronics has been around for decades in education, but at this very moment in time, we're just introducing a range of new kits for automotive. And so what John will explain to you in his presentation today are these new kits. We already have a range of automotive kits which have been in use across many schools, colleges, throughout the globe. We work very much in the US market with TechEd Systems, and as Jeff mentioned, with Megatech and others. We also have a whole host of automotive users within industry as well. And I know Beth, who's on the call, mentioned briefly about adult learners. The kits that we will discuss and present are used a lot throughout automotive manufacturers, companies like Ford, Tesla, Hyundai, Mercedes. All of these companies use our automotive kits for training of their technicians, whether they be young technicians just starting out, or whether this be upskilling or refreshing their technicians with training content. The kit includes demonstration panel. I have one right here next to me. I'll just switch the camera briefly, and you'll see that. So the kits are capable of being used as sort of home use kits for hybrid learning, distance learning, potentially as well. So these kits, we had quite a long conversation last week in the electrical sector, are sometimes kits that will be purchased and then sent out with students to use at home. They're very safe, low voltage kits.
Excuse me, Liam. Can you give us a scale of the vertical training panel there?
Yeah, of course. I'll stand next to it. Yeah, no problem. In fact,
okay.
I've got also, this is me. This is the panel, so this can be used to demonstrate circuits to students for home use or within the classroom or the lab. For example, here what I've got before I hand over to John is an example of one of the kits. Okay, so all of our kits are supplied in these storage bins. Within the top there, you've got the components. Okay, so they all sit in the top of the storage bin. So they're really easy to store away, to take lab to lab, or even, as discussed, send home with the students for home use. And so components can be built on the baseboards here so that circuits can be visually seen by the students. Okay, I think they're the only points that I wanted to just outline before we begin.
Liam, if I can add to that, one of the instructors at Eastern Suffolk BOCES made the comment that with their cart that came with the system, and there's an optional cart on casters, that's a locking cart. He, at the end of the session, wanted to look over across the room and see that all of the bins were back in storage. So he marked them. In his case, he had 2 bins per kit, and then you'd have 2 students per kit. So you'd have 2 bins per kit, and he'd have like A and AA. And he could look, quick glance at the end of the class, all the kits are away. So that was his organizational method.
Great. Right, I'm going to hand over to my colleague, John. John, I'm just about to make you the host. And then you will be able to bring in the presentation and talk to people about these kits.
Okay, just confirm for me, Liam, you can see that start of that?
Yeah, I can see that. There's some thumbs up, some nodding of head.
So
what happened?
today we're talking about a new range of automotive products that we've developed. And this is the kind of big picture of what we're offering. There are 6 packs here. Now in the UK, we refer to different levels of education just by a simple number, level 1 to 7 or 8. Level 1 and 2 are typical of what a student would be learning up to the age of 16. So particularly in a secondary school between 11 to 16. Level 3 is probably 16 to 18, and level 4 is a bit beyond that. And with vocational qualifications, it's sometimes difficult to map them to academic qualifications, but that's roughly how we do it. So in this new range, there are 2 packs at level 1 and 2, that's automotive, electricity and fault finding. And then there are 4 packs at levels 2, 3 and 4. We're covering motors, generators and charging systems, ECU architecture and logic, the use of oscilloscopes and high voltage and battery circuits. We also have a couple more products for automotive at levels 3 and 4, which are to do more with how the computer systems in vehicles are working. They use a bus called the CAN bus, and we've got a great product for that. And we're also covering more about how electronic control units in vehicles are working with our automotive sensor control. And those 2 products are unaffected by this new launch. A lot of you, some of you may be familiar with the range of products in Locktronics. And in Locktronics, there are maybe 300 or 400 components that consist of lots of different values of resistors, capacitors, transistors, all sorts of components that you plug onto these baseboards. Now, a big change, as I'm sure you're aware, in the automotive market is that vehicles are now becoming nearly all electric or hybrid, but electricity and electrical drives and electrical motors and generators are the biggest new topic. And to cope with that, we've created this new product, which is a motor generator pair. And it consists of a DC motor and a brushless motor coupled together on a plate with a brushless motor driver. And each of these devices acts as both a generator and as a motor. And they're coupled together mechanically, and with them you can do quite a lot of work in terms of understanding how different types of motors work in a vehicle. There's some details there, and we'll cover this a little bit more later on. As well as that, in a vehicle, one of the biggest problems now is converting one voltage to another. The lead acid battery is 12 volts. New electric vehicle batteries are 300 or more volts, and we have to continually convert voltage up or voltage down. And this is done with particular kind of electrical circuits. And to reflect that, these 2 new parts are up and down converters, and they're converting something like 5 to 15 volts and also 15 volts back down to 5 volts. But the conversion of voltage from one form to another and the efficiency is a key part of what automotive students need to study. And so we've got some new components there. We've also just got quite a lot of new simple components that you can see here. These are all basically resistors or open and short circuits. And very often with students, it's understanding the language of technology that's important. So dead simple, but all we've done is put the equivalent resistances of, say, a bad earth or corrosion onto a carrier, and those are now used as part of the fault finding learning. We've also got a new miniature ECU. Our MIAC ECU has been very successful, both in educational institutions and in industry, to teach how ECUs work, but it is a little bit expensive. So what we've done is we've done a cost reduction exercise, and this is a double carrier. It's a little computer with an LCD display and a few buttons. It's got 4 input outputs. It's fully reprogrammable, and we're basing a lot of what we do on this new component. And of course, everything in vehicles now is digital, and this is the heart of many of our digital teaching packs. We've also got a few new batteries, a couple of new batteries. In the past, most of Locktronics was just done using conventional power supplies, but understanding how batteries work is becoming even more important in modern vehicles than it was in traditional vehicles. So we've got 2 new batteries, a sealed lead acid battery and a lithium ion battery, and they occupy double carriers and they slot into the baseboards really quickly. And I'm going to play you a video in a moment that'll show you a bit more about that. We've also got a circuit breaker teaching how the fusing systems in automotive works is really important. So that's a component that actually has been around for a while, but we're now just incorporating it into some automotive programs. Liam, we've got a video on how all that comes together. I wonder if you can start that for me.
Yeah, sure. You might just need to make me the host again, John, and stop sharing your screen, please. And then I will play that. I've got it ready.
Okay. Have you got it?
Give me a moment. It's the batteries video first, correct?
Yeah.
Okay.
Hello, my name is John Dobson
from
Matrix TSL, and
now what we've had to do, because we're in lockdown, none of us are in work, so we've had to make these videos at home. It's just been a little awkward preparing because I'm not at work at the moment.
I assume you can see that now, correct?
Yes.
Right, great. I'm going to play this.
hello, my name is John Dobson from Matrix TSL, and I'd like to take a bit of your time just to tell you about some new technology that we've got in our forthcoming range of products for teaching automotive students how electricity in vehicles works. Firstly, we've got some new battery components, and these are a lead acid battery. So here we've got a 6-volt lead acid battery at 1.2 amp hours. And as you can see, it's encased fully in a steel can, and it fits onto a double Locktronics carrier, which allows it to be easily slotted into these baseboards. Alongside the lead acid battery, we've got some new lithium ion batteries, and these are 3.7 volts at 2.6 amp hours. They really pack a punch, and these are exactly the same battery cells that are used in Tesla cars. Of course, Teslas have a great deal more than the 6 that you can see here connected together in series. So you can see the Locktronics link carriers connected in series. And that series combination provides around 24 volts. I've tied the 2 earths of these together. So here we've effectively got 2 power supplies, a 6-volt power supply and a 24-volt power supply. I've got a fuse there, and we're going to use that later. Now, just to show you how this works, basically, I've got a coupled brushless motor DC motor pair here. There's a DC motor, there's the brushless motor. They're coupled together mechanically inside this Perspex tube that you can see there. And on this platform, I've also got a brushless motor driver. The power of these 2 devices is the same, both 50 watts, but you can see that's a lot smaller, which is why a lot of them are used in automotive applications today. Unfortunately, they're more complex to drive. You need a computer to generate the 3-phase signals that requires. And this box contain such a computer. You put 24 volts into it and a 0 to 5 volt speed, and tie the outputs to the inputs, the brushless. And as you can see here, we then have a brushless motor driver. So I've just got a small potentiometer that's making a 0 to 6 volt signal for the speed control. Now, this is a great device for doing all sorts of things. So when the brushless motor is driving the DC motor, it is generating DC. It acts as a dynamo. So you'll find about 0 to 30 volts generated there with that experiment. Conversely, when you power the DC motor, the brushless motor becomes a 3-phase generator. Now that's a really interesting thing to have in your armory, of course, because 3-phase is what is used in terms of a generation system inside vehicles. Now, just to show you another use of this, what we can do is put on this small micro ECU. So we'll change the circuit a little. We'll put on a micro ECU. One of the outputs is connected to a transistor, and we'll keep the positive in this system, and we'll put the positive to the positive of the DC motor, and the negative will connect to this transistor. Right, hang on. So the circuit is, I've got a DC motor, the plus is the 24 volts, the minus, or the 0, is connected to this transistor, which is going to switch the ground in. Most often in cars, the ground is switched, not the positive. The transistor is connected to this micro ECU, and what we'll do is we'll just choose program 14 and run that one. And now there's a 0 to 6 volt signal going in to this pin of the micro ECU, and that then is a speed controller. So now I am driving the DC motor with a pulse width modulated signal, and that is making 3-phase coming out of the brushless DC motor, and you can use an oscilloscope to look at that 3-phase signal. And in later experiments, we'll use a 3-phase rectifier there, and we'll show students how that is used in alternator systems. Okay, so that's just a very quick view of the kind of components and experiments that are in our forthcoming motors and generators and high voltage and batteries packs. Thank you.
Okay, John, I will make you the host again so that you can reshare your presentation and continue.
Liam, while John is doing that, how many levels of automotive kits are there, and which level was that?
So there are levels. I think was it the second slide? I think probably outlined that from levels 1 through 4. What we have, the levels 1 and 2 kits. John's going to probably talk about in a few moments. That particular kit that we just saw was more at level 3, which is our batteries kit. Probably getting on for level 4. John, is that right?
That was a mixture of mostly level 3, really.
Yeah. Yeah.
Great.
Now, can you see my screen again?
Yep. Continue. That's
okay,
good.
so let's just go through the packs in a little more detail, Jeff. This is the very basic kit, level 1 and 2, and you can see the learning objectives there. This is something equivalent to what students would be learning in science up to the age of 16. So all the standard stuff about voltage, current, Ohm's law, resistors, motors, switches, solenoids, and you can see the entire pack is there on the right-hand side. It comes with a baseboard, a whole load of components, 2 different workbooks for this, so probably about 25 different learning exercises. And it also comes with some wire wool, some carbon rods, so students can understand resistivity a bit better, and quite a few other little bits and pieces as well. So that's the basic package. Motors, generators, and charging systems. Here we're covering different types of motor. We're covering generation, rectification. We're covering the very basics of motors, including Fleming's left and right hand rules, how diodes and Zener diodes are working. And another thing we're covering just a tiny bit to start with here, and this is level 3 really, is how to use oscilloscopes. Now there's a big difference between training in the UK and the USA. In the UK, the colleges are now very keen that technicians understand how to use oscilloscopes. It's just starting in the USA, but really because cars now are quite complex, understanding how oscilloscopes are used is really quite important. Another pack, sorry, the order's gone slightly wrong. This is a level 1 and 2 pack again, and is fault finding. Of course, the only real reason for training students in automotive is so that they can fix cars. So this is a real key skill that every single technician has to get to grips with. And this is a really nice course, we think, and we introduce an awful lot of material about how multimeters and clamp meters are working. And students get a lot of hands-on experience of finding different faults and the techniques of fault finding. Here's an example. The things that is new is these new little mini clamp meters are very cheap, around $50, and they provide a great way of measuring the current in circuits without having to make disconnections and put a conventional multimeter in the loop. So they're a really neat fault finding tool that's now used extensively in industry. Here's another example of a lighting circuit, and you can see that this is a mid-complexity circuit, and it offers a lot of opportunities for fault finding. So the way we do this is students are given a description of a fault, and they have to work through the voltages and currents at all the points in the circuit, and then they need to understand what the possible causes of the fault could be. And the problem here for automotive technicians is that one fault can have 4 or 5 different causes, and you have to go through a process of eliminating what those faults are. Just to give you an idea here, in the fault finding pack, hopefully this screen will give you an impression of the quality of the curriculum that we generate. Now all of this curriculum is available free of charge, and we hope to release these products at the beginning of January next year. So we're still in the final stages of design. So if anybody wants to see these worksheet packs and give us a comment on that, then we'd really welcome your feedback on the suitability for the American market. Each pack is about 80 pages long, probably about 20 different exercises, lots of notes for teachers. They're really sort of quite well done manuals. Okay, the next one I want to cover is ECU architecture and logic. A few years ago, understanding ECUs wasn't really in the automotive syllabus, but because of the electrification of cars and the amount of technology that's in cars now, they really are a very important part of the vehicle. And so what we've done this time is that in the previous version, this product really just covered digital logic and techniques, but now we're really delving into how ECUs work in a little bit more detail. So we're teaching students about digital technology, the difference between analog and digital, about sensors, about how to drive motors and actuators with pulse width modulated signals, how the basics of transistors and relays work, fiber optics, control techniques, and again, fault finding is a big part of this product in its own right. Here's an example. For example, we've got this micro ECU here. There's one analog input, and we're using a transistor to drive a pulse width modulated motor there, and we're measuring the temperature on another input just with a small bead thermistor. So it's an example of a small thermistor-based heat sensing device. Again, the workbook is quite big, around 80 pages, about 15 or 16 different exercises, going up to a reasonable level of complexity. And hopefully, again, there you can see the quality of the product. Liam, would you like to run? I've got a video now that just shows you in a bit more detail a particular ECU circuit, and perhaps you could run that video.
I'll just run that now.
Yeah, you're the host now.
Yeah, I've just seen that. Thank you. Okay, ECU video, sharing my screen. Everyone can see that.
Hello, my name is John Dobson from Matrix TSL in the UK, and this video concerns our new ECU and digital logic course for automotive students. Now in front of you, you can see 3 Locktronics baseboards which are all pushed together. And in the center, what we've done is we've constructed an electronic control unit, or something that mimics an electronic control unit from a car. And at the heart of this, there's a small micro ECU. Now this micro ECU has 1, 2, 3, 4 inputs and outputs. It has power and ground and a small display. And what the students can do is they can select one of 15 programs using these switches and then press OK. And each of these programs carries out a different function that is typical in an ECU. Now around the ECU, here we've got a couple of inputs, and they've just got resistors going from the outside world into the ECU. And here on this output, we've got a power transistor. In this case, we've got a bulb on the power transistor. And here we've got a power transistor feeding a relay. So on these 2 outputs here, we've got a relay, and on this output, we've got a transistorized output. Now, basically, this is the system. Over here, we've got the outputs, and over here, we've got the inputs. And students construct various different circuits, which teaches them how ECUs work. Now, to demonstrate this, we're going to look at the concept of pulse width modulation, which is used to deliver varying powers to things like lights and motors in a vehicle. And just to help students understand the concept, we've got a bulb on there, and I'm going to choose program 5. And program 5 says slow PWM, you press OK. And what program 5 is doing is it's varying the output onto a bulb. And the switches control the output. So at the moment, the bulb is on for a short time and off for the majority of the time. If I alter these 2 switches, then you can see it changes. Now it's on for half the time and off half the time. And if I do this switch, now you can see it's off for a very short time and on for a longer time. And those 3 settings just demonstrate the way that different powers can be delivered to that bulb. Now, of course, most of the time we want to control motors. So I'll just reset the micro ECU. We'll change the bulb for a motor, and we'll select program 6. And program 6, rather than doing it slowly, has a very fast output. The output there is going at 1 kilohertz. Now, the switches just vary the mark space ratio output to the motor. So when both switches are open circuit, you can see that there's no power to the motor. When one switch is pressed, there's a certain amount of power, and when both switches are pressed, there's a lot of power. Now, what students can do is they can put an oscilloscope on the output, and they can use the oscilloscope to look at the waveform being delivered to the motor. Okay, now with this kit, there's about 15 experiments covering analog, digital, thermistors, potentiometers, sensors, all sorts of different types of circuit that students find in a vehicle, and it also covers some fault finding with ECUs as well. Okay, thanks for watching.
Okay, I'll just make you the host again, John, and you can continue. Okay. Good.
Okay. The next pack then at level 3 and 4 is about high voltage and batteries. This is a huge topic now in automotive. With lots of electric vehicles, the batteries and the way those batteries are handled is incredibly different to how we used to handle the conventional lead acid batteries in cars. And students need to learn an awful lot about how to test different batteries, about the different types of batteries, how they're charged and how they're managed, how smaller batteries can make up large batteries, about DC to DC converters and three-phase. Residual charge on batteries is a huge topic. You have to be very careful when carrying out any work on an electric vehicle to make sure that the batteries really are disconnected. 300 volts is capable of easily killing people, and there are a lot of devices that have residual charge in a vehicle. So that's a big topic for us. Also, a little bit more about maybe the semiconductors inside vehicles as well. So now to do that, we are using, this is a good example of the kind of system that students can construct. So you saw in that video, there was some lithium-ion batteries making 24 volts. In vehicles these days, there's a double relay used to disconnect both the power and the ground. So there's a relay disconnect system. And in this system, it's a kind of made up system, but it covers an awful lot of technology that you find in vehicles. So what we're doing is we are using a single switch from a 6-volt lead acid battery there to power the two relays. That connects the power to the DC motor, which then creates three-phase. That three-phase is rectified by this three-phase rectifier. It's passed through a couple of meters to a large capacitor. That capacitor voltage is around 7 volts. We then up-convert the 7 volts to 12 volts, and we charge these two lead-acid batteries. So it covers huge amounts of vehicle technology. Now, of course, you'd never have a system like that because all it's doing is using energy, but it shows all the chunks of technology that you find in electric vehicles. So that's an example of the kind of things that students are doing in this pack. You can see there again the workbook. All of these workbooks have the same look and feel to them, and hopefully you can see that's quite nice. Okay, the last thing we're doing, we're not as far on with this product as we'd like. As I mentioned earlier, the use of oscilloscopes is now getting bigger and bigger in motor vehicles, but actually oscilloscopes present students with a problem, and that is how to use oscilloscopes. Triggering oscilloscopes on all the different waveforms in cars is a real headache for students. And so because of that, we've made a small device. It's just a small circuit board sandwiched between 2 layers of plastic, and it contains 20 different oscilloscope waveforms that you come across in a car. So this product's very simple. It just generates different waveforms, and it allows students to trigger their oscilloscope on those waveforms. And we've got a good prototype of that up and running, but it won't be available for another 2 or 3 months. Okay, so as a reminder, I think we're coming to the end now. These 4 or 5 new curriculum products are now ready for you to have a look at. The one that's missing from there is, well, I can't remember, but there are 5, I think. If you'd like to see these, just get in touch. Liam can send them to you, and you can have a look at these curriculum packs, and we'd really welcome any feedback that you might have. Okay, so that concludes
Cheers,
my
John.
presentation.
Great, thank you. Right, okay. So just a few things to wrap up then before we take any questions from myself is I want to get across the message that what we have presented today are the range of new kits that we've got for automotive. Our automotive range of Locktronics has been in use within schools, colleges, and at manufacturers such as the ones I mentioned earlier for many years. These are new kits that we're introducing. Many of these new kits are most used at the higher levels of study, and some of them are, I would say, ahead of the curve in terms of what students might be studying, for example. but I still don't want that to take away from what we've got at the most basic levels. The first two kits that John presented today were the basic automotive electricity kit and the fault finding kit as well, which would be used, as we say, at level 1 and 2, so the higher end of the secondary school market and into the community college market as well. I also just want to briefly share my screen with you whilst I show the Matrix website, because John did touch upon the fact that we at Matrix provide all of this curriculum for free. Now, we do that through our learning center. This isn't just true of the automotive products that we focused on today, but if you visit our website, matrixtsl.com, and you go into the Learning Center, which can be accessed in two places, under Support, Learning Center, and also there's a button on the home screen here for the Learning Center. All of our curriculums are freely available here. If you filter this down to automotive by subject area, you'll find all of our automotive curriculums. Now here at the moment, you'll find our existing kits, but these new sets of equipment that John's just presented to you this morning are going to be on here very soon, and I will ensure that we send you the beta copies as a follow-up to this webinar session. So if I were to just go into, for example, let's go into what we currently have on there for electricity. This is the most basic kit that we do. We've slightly changed this for the basic automotive electricity kit, but here you'll find all of the worksheets. This is basic stuff on circuits, switches, fuses, symbols and circuits and resistors. Typically, this will be used within a science session, so within STEM classes, or it might be used within basic engineering classes as well. And the worksheets are really straightforward for students to follow. They can be self-taught from home, for example, as well. Further on towards the end of each curriculum, you'll also find teachers' notes and teachers' guides as to how they should deliver this. So rough timings and estimates on how long should be spent on each session is all focused on in here. And what I want to get across is that all of this curriculum is free of charge. There's no sign-in or anything. You can go there now after the call and have a look and find access to all of this. And Matrix as a company, we have products across many different areas, and you'll be able to find all of the curriculum within here. I did just want to also briefly touch upon safety. John, in some of his presentation there, talked about high voltage batteries, for example. Everything that we're doing here is safe. We're doing work here at 0 to 30 volts. I'd even say that the kits are suitable for students to use at home, no more dangerous than them plugging in, for example, an Xbox or PlayStation console. And so they're certainly, because of the way that we store them and provide them, capable of being used on a home basis as well. Lastly, I wanted to just reiterate the fact that these kits for automotive in particular are used across industry widely by many manufacturers. As I mentioned earlier, they're also used in heavy goods industries, companies such as Iveco, Scania, and agricultural technology centres, colleges, universities, and industrial providers as well. So there's a real broad